So, going to go through this minorities data, and it's available on the website as minorities.html, and you can cut and paste from that. It's a R Markdown file. I can't remember whether I put that up on the website or not, but it's certainly a vignette inside Loon. If you download Loon, you'll be able to find this as well. So, just to remind you, just quickly, last day, this is Stats Canada data, and it's looking at the population of visible minorities in 33 different cities across the country. And so we have these particular categories in alphabetical order, probably easier to see here with the cable, and have the population numbers. It counts in for each person that self-identifies according to one of these different visible minorities, and the total population of each city as well. So we went through a bit of work to get the latitude and longitude from different sources, noticing the problem with the Google source being the location of the actual province rather than the city of Quebec. And we did a little bit of work including taking all of those huge labels, like visible minority not included elsewhere. I think that those people turned into other. Doesn't sound very nice, but it's at least shorter. Yeah, so percent of other. And you've just shortened these up so that we can actually see them in the display. So you recall that we looked at, the percent of visible minority in each city, like percent of visible minorities out of the total of the city, and then also which minorities were the three largest percents across the country, and then look where they were distributed via those interactive histograms. And then built a map, and we looked at the map of the country with lots and lots of layers, and overlaid that with some glyphs. So I'm just going to get down here. Oh, the other thing we did was looking at, kind of interesting to think about the proportion of each visible minority within that city. So that was related to, like we did with the iris data, where we were interested in not so much the size of the flower, but the relative shape. Similar sort of thing here. And I think now we'll just look at this, we'll talk about it through the serial axes themselves. So here's the parallel coordinate plot. And it's kind of a crowded screen here. But if you had it looks nicer on a big screen, maybe not so bad up there. You notice the inspector has adapted to the serial axis plot. And we have the shortened labels here. And the scaling here is, it's a parallel coordinate plot. The scaling is according to variable. And that means when we're mapping the variables to, say, Southeast Asian here from 0 to 1, the scaling, where it appears there, is going to be according to the largest value of total population for Southeast Asian population across the all 33 cities. And so that's why we see this one particular city appearing across the top, and I have show item labels on, so you see that that's Toronto. So we're looking at the magnitude of the city roughly there. So it has the largest visible minority population across the country on all but two of these categories. The two categories being this axis, the Japanese, and this axis, Arab. And so you might see who's the largest in the Japanese. We looked at that before, and that's Vancouver. Who's largest on the Arab, and that's Montreal. And then you may select this. That's Montreal. Also seems to be very large. Stands out in some other regions, as does Vancouver. Again, because they're both large cities by Canadian standards. So stop me if you have any questions. 'Cause I'm gonna, yes? These are actual numbers, but mapped to 0, 1. So that's why this, if they were proportions, it may be that it's going to be, Toronto's not going to figure so prominently. So they are mapped over all cities, looking at any one of these minorities. The largest of those goes mapped to 1, the smallest gets mapped down to the bottom here. So that's why you see Toronto at the top. Let me just switch this to radial axes, because that's also gives you some sense of shape now. So now cities have a particular configuration, and again you see Toronto being the large city there, and this is Vancouver also being large, but not having nearly as large a population on the Arab axis here as does Montreal. And you see by the shapes here, Montreal has a particular shape, Toronto has this massive shape, and Vancouver has a shape. But that's confounded or conflated with the size of the city. So a simple switch is to look at, you see the scaling here on the inspector. I could have it by observation. And that means every observation is a city. So now the largest value, right, for any one of those glyphs, just looking at one of them, let's just take one, invert this and deactivate the other. So looking at any one of these cities, it's going to have 1 on one of these axes, and there'll be probably less than 1 on all the others. Right, so this particular city, the largest axis is South Asian. So that's that's the largest visible minority in that city. Okay, so it's a nice scaling. Now you're getting a sense of what's the distribution of visible minorities within a city being mapped to the shape of the glyph. Okay. So everybody understand that different mapping, right? So we take that. I'm going to keep that up because that's kind of fun easy to read what we're looking at. If I can find a spot for it. I can make this small enough so that you can just read the axes. I want you to be able to tell which axis it is, because that makes for a bit of fun. You can still read that? Yeah? Okay, let's make that small. And now bring the map up. So here's the map. And we can see across the country what these different cities look like across the entire country. And these are colored from the west being sort of on the reddish to the brown, out to the east being on the turning into purple. So it's these terrain colors that are moving across the country. So we got the color to kind of identify where the location is in the country as well, at least in terms of longitude. So looking at this and zooming in, again from the west coast here, we can see which guys look alike and which look different. And certainly there's a fair variety of shapes here. And we see here on the Victoria, maybe looks a bit like Vancouver. Let me just make these all a little bit bigger so it's easier to see. Select them all. Okay, so they look a little bit bigger. Vancouver here, that's Vancouver, and Victoria have very similar shapes. I mean, Victoria's a little fatter here in this little wedge, and Vancouver's seems to be a little thinner. If we look at what those are, we get some sense of the makeup of Vancouver. So in the Vancouver distribution of visible minorities, the Chinese population is the largest, followed by South Asian. Hardly any Japanese by comparison. Hardly any Southeast Asian or Latino or Korean. These other areas are, it's largely dominated And remember, these aren't absolute numbers, these are proportion, right? With Chinese being the largest, dominated by the Chinese and South Asian communities. And if you look at Victoria, it's largely the same with a little more Japanese appearing here, which is making that wedge look a little fatter, right? Make sense? So those two look kind of alike, and it's interesting to see these other guys that look alike, and they're near each other spatially. So you've got this relationship, the distribution of the minorities, and where they're located in the country. So that may not be too surprising, right? Nearby cities should look a lot alike in sort of the distribution. But what's interesting, of course, is these two cities look very different from anything around. You can almost imagine going from the west to east and these little guys morphing, right, into different shapes. But these ones are really quite different. So this is Kelowna. So if you look at Kelowna, there you're seeing a very large dominant South Asian population and Japanese. Japanese is what's pulling this bit out, making that very, very thick. So there's a large Japanese population there, at least as a proportion of the visible minorities, as well as Chinese. So you've got South Asian, Japanese, Chinese, some Latino. And I wonder if I can make, if that's more helpful, if I make these guys all showing the area. So now when I select it, it'll look a lot like the glyph, right? And this one's really weird. It looks like it's got one really hugely dominant visible minority. This is Abbotsford Mission, and that's a large South Asian population. And so now you might want to go and look at these cities and see what is the distribution there. Are there particular, since it's largely a country of immigrants, to see where one particular group entered. Yes? It's whatever Stats Canada tells me is the city of Vancouver. So for example, where we have one thing, and we are Kitchener, Waterloo, Cambridge. So and why these particular cities? I mean, why Abbotsford Mission and not in Kelowna, and why not Prince George? And I don't know how they're selecting these. But it's kind of interesting that is an outlier, very different from what's around it. And it gets more interesting out here actually, because it's not surprising that this is Edmonton, Calgary, Saskatoon, and Regina. So you have Alberta and Saskatchewan, prairie provinces. It's perhaps not too surprising that they don't look too different from each other. Alberta has this spike up here on this top axis, which again we'll see that's the South Asian axis. So South Asian and Chinese being the ones that are dominating these things. And down here, Filipino and Black. And as we move east here, we're seeing this one coming down, the South Asian coming down, and the Black going up, and same here. And now what's this bottom bit here? Okay, I think that's largely the Latino that's pulling that thing out. Where it gets really interesting, and I was there this summer, is this thing which I jokingly called Manitoba's provincial bird, right? This thing that looks very much like a mosquito is very unusual. That long proboscis there is Filipino population, and for reasons that I don't know, but there is a large Filipino population in Winnipeg. It's a large visible minority population, and that is surprising. So you learn something about the data here, that this city is rather different from these other nearby neighbors in very interesting ways. Get down to Thunder Bay here, and you have large Chinese, Japanese, Southeast Asian, and Black not so many other, not so many Filipino, not so many Korean. So just moving along. So that one's a little different. We get into Ontario, and we're starting to get a southern Ontario. We're getting a little more common shape. A sort of star shape everywhere here, with this high top axis and large corner over here. So this, for example, what is this? This is very, so you see large, I think the largest is black here, and South Asian. And so we're seeing this more, you know, is this characteristic of Southern Ontario, the shapes. These certainly look a lot more alike each other than they do like the Prairie Province ones, for example, but also have interesting differences. And if you go visit these cities, you might think about, do you actually observe this difference? So this is London, I guess. London having a large Southeast Asian, which is pulling out this massive Latino population and Arab population, which is rather different from everybody else. And I think, in fact, Windsor here is unusual, having a large Arab, large black, large South Asian, and almost as large Chinese. So you can see that they look different, and you imagine the visible minorities are different. The more you know about the country and immigration patterns, the more interesting this becomes, because if we move east here, you're starting to see another shape. And so looking at this, now it's not unusual to see, like, the black is the largest of the visible minority, but that the Arab population is quite large. And you can again imagine why that might be, knowing where we are, right? This is in Quebec. And you again think about drawing immigrants from Francophone countries, right? And so if you're going in by linguistic means, it's not too surprising. And moving across the country, and again, slightly different here in the New Brunswick and Nova Scotia, with, relatively speaking, a large black population. This one has almost as large Chinese. And there are historical reasons going back even to the Revolutionary War of people coming up in the Revolutionary War being granted freedom, former slaves. And so this is a long established historical population. So yeah, so slaves are granted freedom if they fought on our side, as opposed to the American side. So, very interesting story. You get to see this, looking at this relative distribution, whereas if I had taken this thing and now, notice that with the inspector I have another tab here called glyphs. I have these stars, and I have these selections that can be made as well. So I can, let's see, change the variable. So now you see massive blob that's Toronto, right? And you see the relative size of all of these things. So it's mainly population that we're seeing here. So you got Toronto, Montreal is underneath there as well, in Vancouver. And again, switching back to the observation so that every city is at least on its own footing, standardized by population. Other thing you might do is, we had another scatter plot here. Here are all of the glyphs again on top of each other, and I'm going to have these not show their area. Oops. Not show well, leave the axis if we want. And now it's kind of interesting, not knowing where these are, to move these around, you know. This is what we're talking about with faces or anything else. Can we move these things that seem to be a lot alike? So these are the guys that look a lot like those guys. And you can start to group things that, into some kind of clustering, right? See whether or not there's cities that seem to be a lot alike. And if they're a lot alike and also spatially near each other, that's again interesting. Okay. So finally, I guess these are all linked with any of these histograms, so we could stack the colors here and see what the distribution is. You know, select any of these cities and see where they are in the histograms. So that's a quick whirlwind tour of using glyphs and interactive graphics with spatial stuff. So all of the stuff working together to get higher dimensional data. This, how many dimensions do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 dimensional data. We could also pursue this a little further and say, but you know, maybe we're seeing these strange things and patterns because always it's you know, South Asian is beside Japanese, Japanese beside Chinese, so we might want to have change the order, right? Do an Eulerian on all of this so we have every pair appear, or maybe just the most interesting pairs that are pairs that appear beside each other that are perhaps most highly correlated with one another, etc. So you could use all of that technology we did before and build more sophisticated glyphs as well. Any question? Yes. Yeah, so of the visible minority populations, the one that was the largest, and so there could be like 10 people in the whole city, right? But if 5 of them were one particular flavor, that gets the one, that's the longest one. And you know, the next longest proportionally will be on the next axis. It's half as many, yeah. It is proportionate. And I guess again you could think about transformations too. If they were very skewed, and you wanted to really see the differences between those small ones, so you'd end up logging them first, right? So it may be, in fact, that all these big axes are not the interesting pieces. The interesting pieces are the little tiny ones, right? In which case a log transformation before may be the thing that will see subtle differences. Okay. Other questions? Has anyone tried this? Try it, okay? Because it's one thing to watch me march through this, but actually try it yourself and explore with it. And if you follow that vignette, that HTML, it talks about all of the stuff and probably a little more coherently than I'm making the points today, right? Okay.